Alright, today we're going over 4.7 inverse matrices and systems. So let's take a look here. We're going to start by looking at a system of equations. So you can represent a system of equations with a matrix in a matrix equation. So we're going to take this system of equations and we're going to rewrite it so that it's a matrix equation, and then we'll solve the matrix equation. So we're first going to look at all of the coefficients. So if there's no number written in front of the x, we know that the coefficient is a 1. So we'll have our coefficient matrix where we just write our coefficients. Okay, and this is the start of a matrix equation. So we have our coefficient matrix where we have all of our coefficients. 1, 2, 3, 5. 1, 2, 3, 5. Then we'll have our variable matrix where we'll just have x and y as our variable matrix. And then finally, we'll take 5 and 14, and those are going to be that's going to be part of our constant matrix. And we're going to learn how to solve this using the matrix equation. Okay, so writing a system as a matrix equation. So for this one here, we're going to write the system as a matrix equation and identify the coefficient matrix, the variable matrix, and the constant matrix. We're not going to solve this one yet. We'll solve one of these in another slide. So if there's no value of A, you do have to put 0 for your matrix. So let's just write in what's not there. Okay, there's no B here, so I'm going to write in 0B. So writing in the coefficient matrix here, I have 0, -1, because this is a -1 here, 2, then I have 1, 1, -1, for here, 1, 1, -1, and then the last one is a 2, 0, and a 3. Okay, so this is my coefficient matrix. Then I'm going to have my variable matrix. My variables are A, B, and C. And in order to multiply these, I need it to be written so that I can multiply them. This matrix is a 3 by 3, and I wrote this matrix as a 3 by 1. And we know that we can only multiply them when these numbers are the same, which is why I wrote it as a 3 by 1 as opposed to a 1 by 3. So we know that the new matrix, when you multiply them, will be a 3 by 1. Those will be the new dimensions when you multiply them. Okay, so the A, B, and C, that's your variable matrix. And then that will be equal to your constant matrix, which is 4, 0, 11. And it's just whatever the equations are equal to. Here's your constant matrix. Okay, so we're going to solve these by using matrices. So we'll first write it using our coefficient matrix, our variable matrix, and our constant matrix. So writing this out, we have a 2, 3, 1, 2. That's our coefficient matrix. And then we have our variable matrix, x, y. And that is equal to 11, 6. So in order to solve this, let's call this matrix A, okay, the 2, 3, 1, 2. In order to solve it, we need to find the inverse of matrix A. So matrix A is 2, 3, 1, 2. That's our coefficient matrix. And we're going to find the inverse by finding the determinant first. So the determinant of A, we know we're going to go A times D, so 2 times 2, minus B times C, 3 times 1. So I have 4 minus 3 is 1. Okay, so moving on here, I'm going to take my A inverse, and I know that A inverse is going to be, I'm going to use 1 over the determinant of A, and I'm going to multiply that by, I'm going to switch A and D, those are switched, and I'm going to negate B and C. Okay? So the determinant is 1, so it's just 1 over 1 times, I'm going to switch A and D, so those are both 2's, so it doesn't look like they're switched, but you would if they were different numbers. And I'm going to negate B and C, so -3 and -1. So this is the inverse of A. A inverse is equal to 2, -3, negative 1, 2. Okay. So now what I'm going to do is I'm going to multiply both sides by A inverse. So multiply both sides by A inverse here, and we know that these two are going to cancel out. So you'll have x, y, and then I'm going to have A inverse, which is 2, negative 3, negative 1, 2. And I'm going to multiply that by 11, 6, my constant matrix. Okay, so multiplying that out, I'm going to go row by column now for this. Oops. Going row by column to multiply this out. Row by column. I'm going to get 2 times 11 is 22. Negative 3 times 6 is a minus 18. Okay, and then doing the same thing, row by column. Now we're multiplying this row and this column. Negative 1 times 11 is negative 11, plus 2 times 6 is 12. And to finish that up, we have 22 minus 18 is a 4, and 12 minus 11 is a 1. And that's our answer. So x and y, we just found that x and y is 4, 1. And you can write it as an ordered pair as 4, 1. You can also check this answer by plugging these into both of the equations and making sure that it's correct. So if we plug this in, we get 4 plus 2 times 1 is 2, and 4 plus 2 is 6. Plugging this one in, 2 times 4 is 8, 3 times 1 is 3, and 8 plus 3 is 11. So that checks out. Okay, let's move on to 3 by 3s. So this is a good one to watch, especially if we missed the lesson in 4.6 where we had to do the inverses of 3 by 3 matrices. That's why I have these little blue things here to cover up the wrong column. Okay, so let's take a look. This one is nice and long, but it's not very difficult. Let's get started. Okay, so we're going to start it the same way, just by writing out our coefficient matrix. 2, 1, 3, 5, 1, negative 2, 1, negative 1, negative 9. Let's make sure that we wrote it all correct. That's the first thing, and looks like we're all set. Okay, that's good. We're going to write our x, y, and z, our variable matrix, and our constants, 1, 8, and 5. Okay, so just like our 2 by 2 in the previous problem, with the 3 by 3, we have to find the inverse and then multiply both sides by the inverse. So let's take our matrix 2, 1, 3, 5, 1, negative 2, 1, negative 1, negative 9. And I'm going to first start by finding the determinant. So I'm going to do that by rewriting the first two columns, 2, 5, 1, 1, 1, negative 1. Okay. Making sure that it's all correct. And we're good. Okay. So now we are going to find the determinant. We can call this matrix A. So right now we're finding the determinant of matrix A. So when we find the determinant, we're going to do this by multiplying the diagonals, starting this way. 2 times 1 times negative 9, multiplying all of these diagonals out. Okay, so we get negative 18 here. Negative 18. Make sure you go nice and slow for this so you don't mess up. If you mess one little number up, then everything will be off. Alright, multiplying this, 1 times negative 2 times 1 here. That's a negative 2. 3 times 5 times negative 1 is a negative 15. Okay, so I'm going to add these up. That's going to give me a negative 35. And now I'm going to go the other way. So I'm going to subtract off what I get the other way. Okay, so starting here, I go 1 times 5 times negative 9 is negative 45. 2 times negative 2 times negative 1, that's going to be a 4. And 3 times 1 times 1, that's going to be a 3. So adding all of these up, that will give me a negative 38. So minus a negative 38. So this is negative 35 plus 38, or 38 minus 35, is going to give me a determinant of 3. Okay, so now we have the determinant. The determinant of A is 3. There we go. Okay, so now, moving on, we're going to find the inverse. So, we know that we're going to start with we're going to take each row and we're going to turn it into the columns. So we know that for the columns, or for the rows here, every row 1 will become column 1. Okay, so I'm going to look at these and I'm going to cover up the ones that I'm not going to be using. So I'm using right now the first one. I'm using row 1. This is the one I'm finding the cofactors for. Okay, so the first one we look at is the 2. So I'm going to cover up the row. Well, it doesn't really cover it up, but you get the point. It's easier to see it, kind of. Okay, so we're going to cover up the row and the column, and we know that we're going to have the matrix that we're using for the signs here. That doesn't change, so that's always plus, minus, plus, minus, plus, minus, plus, minus, plus. And this is what we're multiplying the 2 by 2 determinants by. Okay, so let's get started. We're going to multiply this 2. That element is a plus because of this sign here. Plus, and now we're going to write down the 2 by 2 matrix that's left. 1, negative 2, negative 1, negative 9. And we're going to find the determinant. So we have A times D, negative 9, minus B times C is a 2. So negative 9 minus 2, that's going to give us a negative 11. Okay, then moving on here, we're going to do the same thing for the next one, covering up the row and the column it's in, and then writing what's left over. So now we have a negative, and now it's going to be 5, negative 2, 1, negative 9. Finding the determinant here, and then we'll have to multiply it by a negative. So we have a negative 45 minus a negative 2. So bringing down that negative, we have a negative 45 plus 2 here. That's going to be a negative, and then this is a negative 43, and a negative times a negative is a positive 43. Okay, and then the last one for this row, oops, wrong one. The last one for this row is, moving this one over, we have a positive sign, and then covering up the row and column it's in, and we're left with 5, 1, 1, negative 1. Finding the determinant of this, we get a negative 5 minus a 1 is a negative 6. Okay, so this row 1 is now going to become column 1. So let's start the inverse here. This is A inverse is going to be 1 over the determinant of A times all of the cofactors. Okay, so we can fill that out too. So we already found the determinant of A to be 3. So we're going to fill that out. So we have A inverse is equal to 1 over 3. We'll multiply that in after we find all of the cofactors. So this was row 1 is now going to become column 1. So it's negative 11, 43, and negative 6. Okay? And we can check this after we do all of our work, show all of our work. You can check it in your calculator once you're done with that. All right, so moving on, now we're going to do row 2. Okay, so row 2. Row 2 then is going to become column 2. So here we go, row 2. So let's move these so that we can do it. So we're going to move it so that this is row 2. And we'll start with the first one here. Whoops, not that, not that. Okay, there we go. Too much going on now. All right. So we're just trying to cover up the row and column that it's in. So now we're looking at row 2. So writing what's left, we have a 1, 3, -1, -9. Okay. So let's see here. I'm going to just erase this so that we can see all the work. Or actually, we could just take this and move this down. Okay, remove this down so that we can actually see what we're doing. All right. That should be better. Okay, so now we're going to do it for row 2. So covering up the row and column, and we're still using the matrix that's telling us the sign that we have to use. So we're taking this now, and we're going a negative, because that's the sign, and writing 1, 3, 1, 3, -1, -9. Okay, finding the determinant and bringing that negative down, we get a -9 minus a -3 here. That's a -9 plus 3. Bringing that negative down, this is a -6 times a negative is a +6. Next one here, so we're going to move over this blue over so that we cover up this row and column now. Okay, and now it's a positive, so I have positive, and now I get a 2, 3, 1, -9. And finding this determinant, we get a -18 minus a 3 is a -21. And the last one here, covering up the row and column so we can see what's left. And this will be multiplied by a negative, so a negative. Writing what's left, we have a 2, 1, 2, 1, 1, -1. Multiplying this out, I get a -2 minus a 1. Bringing down that negative, I have a -3, which will change to a +3. Okay, so we can write these in now. So this becomes 6, -21, 3. 6, -21, and 3. Okay, because row 2 becomes column 2. And now the last one. So now we'll do it for row 3, and that will become column 3. So let's move this down here. That's good. Okay, so last one here. Let's see what we got. Okay, so now we're going to move the blue so that it's covering up the one that we're working with. So we're doing the last row now. So the last row is what always needs to be covered. So now we're doing row 3 will become column 3. All right, looking at the signs, we have a plus, and then we look at what's left once it's covered. 1, 3, 1, -2. That will be a -2 minus a 3 will be a -5. Okay, continuing on, we cover up the row and the column that it's in. So covering this one up now. There we go. And this is going to have a negative sign, so a negative. And then we write 2, 3, 5, -2 here. Bringing down this negative and finding the determinant. -4 minus a 15, negative, and then this is a -19, which becomes a +19. And then finally, the last one here for our cofactors, moving this, moving this to the last column. There it is. And this is going to have a positive. Covering it up and writing our 2 by 2 that's left over is a 2, 1, 5, 1. Finding the determinant, 2 minus 5 is a -3. Okay, so we're going to write this in to finish up our inverse. -5, 19, -3. Okay, so now we just have to multiply in our scalar. We multiply in 1/3, which is the same as dividing by 3, and then we'll write down what our inverse is. Excuse me. So we have a -11 over 3. We have 43 over 3. We have a -6 over 3, which is a -2. We have 6 over 3, which is a +2. -21 over 3 is a -7. 3 over 3 is a 1. Then we have -5 over 3. 19 over 3. And -3 over 3, which is a -1. So this is the inverse. There it is. Okay, now we're almost done. So now, well, kind of almost done. Okay, so now we're going to take this. The computer is a little delayed with circling it. So now we're going to take our inverse and we are going to multiply both sides of this matrix equation by our inverse. So we know that the A inverse and the A will cancel out. And then I'm going to multiply this side by A inverse. So I have A inverse times 185 to find x, y, z. Okay, so here we go. This is the last part here. So we're going to take that and we're going to rewrite it. So this is finding x, y, z. All right, so here we go. We have -11 over 3, 43 over 3, -2. We have 2, -7, 1, -5 over 3, 19 over 3, and -1. And we're multiplying that by the constant matrix, which was 1, 8, 5. So now all we have to do is multiply each row and column. Okay, so we can multiply that out. So we'll go each row by column here. It's starting to slow down again. And we'll see what we get. So multiply this out. You can also check it in your calculator once you're done. You should check your inverse also to make sure that you got the inverse correct. If you didn't, look at your cofactors and see if you got it accurate. Once you multiply all of them out, you should get 4, -10, and 1. This is your x, your y, and your z. And then, of course, you want to plug it in to make sure that you got the correct answer. And you can write it as an ordered triple: 4, -10, 1, and that's your x, y, z. All right, moving on. Next one here is write the coefficient matrix for each system. Use it to determine whether the system has a unique solution. So if we're looking at the coefficient matrix, 1, 1, 1, -1, we want to find the determinant. And if the determinant is 0, then it does not have a unique solution. So let's make sure that this one does. We got -1 minus 1, because we do AD minus BC. So -1 minus 1 is a -2. This one does have a unique solution, yes. This one is 1, 2, 2, 4, writing down the coefficients. Finding the determinant, 1 times 4 is 4, minus 2 times 2 is 4, which is a 0. So since the determinant is 0, this does not have a unique solution. No unique solution here. Okay, and then this one here, last one, I believe. And yes, okay. So if we look here, this is talking about a bead store has a sale on certain beads. Find the price of each size of bead. We have 2 large beads and 3 small beads is this amount. 3 large beads and 4 small beads is this amount. We're going to let X be the large, Y be the small. So we're going to write this out. 2, 3, 3, 4. You can write it out as an equation if you want. The large beads are X. So this is 2X plus 3Y equals 325 And then this one is 3x plus 4y equals 475. And then writing it into a matrix, 2, 3, 3, 4, and then xy is equal to our constant matrix, 3.25 and 4.75. You'll find the inverse of this. So we first find the determinant. 2 times 4 is 8. Determinant is 8 minus 9, which is a negative 1. And then we know to switch A and D. Switch A and D, 4 and 2. Negate B and C, negative 3 and negative 3. And then we multiply it by 1 over the determinant, which is negative 1. So this will become negative 4, 3, 3, negative 2. So this is our inverse. And we're going to multiply both sides by that inverse. So we have x, y will be equal to negative 4, 3, 3, negative 2. Multiplying that by 3.25, 4.75. Multiplying each row and column. And we will come out with x and y to be equal to 1.25 for your x and 0.25 for your y. And this is telling you the price for the large bead and the price for the small bead. And that's going to wrap up 4.7. Thanks for listening.